Okay, welcome back. What I want to continue with now is session 6, requirements of testing, and you will look at, remember that unit 5, I should say session 5, was to do with testing itself again, but it's this process is quite a lengthy process, so it's important that you understand and you meet the requirements and specifications at each stage. Okay, so section 6, requirements of testing 1. Okay, unit 307, and we're still working with unit 307. Excuse me. Okay, so I was just trying to make sure that I got it in frame fully, so just bear with me while I make sure that these are in frame and they're good. Okay, revision. Okay, no need to take too long on this. Okay, as a matter of fact, can work for these now at all ledger. And here requirements for testing 1. Okay, okay, continuity test. Okay, and let's make sure that we get it fully on screen. Okay, nothing for me to speak there on about, because you would have done a lot of this already in practice. Okay, so that's enough for you basically. But protection against electric shock. Okay, and again, and verification or verifying continuity, but just for, but I'll just simply call it verification. Okay, now here, look at the parallel paths. Now the continuity test must be carried out prior to the connection of any supplementary bonding conductor or main protective bonding conductors. Okay, right? And what it's trying to say here is that if protective bonding conductors are connected, then you may not be testing just the CPC. You may also be testing a parallel combination of earthing and bonding conductors. Okay, so you have to take that bear that in mind. So here we have the parallel paths, and those parallel paths you need to take into account. Okay, Now you can see here that here you're testing to see whether or not there's any connection between the live conductor and the CPC. Okay, if obviously if there's a connection between the live conductor and the CPC, then you're going to have a problem. There's a fault. It will trip your circuit breaker. Okay, and what is this saying here is that these are your parallel paths. Okay, if you have resistance in parallel, then it tends to cause a reduction in the overall resistance total value, which can give a false reading. Okay, basically, so between your live conductor line and the CPC conductor, the resistance needs to be high, very high. As a matter of fact, it should be in the megohms value. Let's just go in close so you can see this for yourselves and make sure that you understand the concepts behind it. Okay, this pipe here could represent your water mains coming into your house, but as these days most water mains coming into the house is now plastic. Okay, and even the central heating is now in plastic. Okay, so I'm coming back on that fully. Okay. Now, all we're doing here, we're using the earth here as a means of continuity to check that we have continuity between this circuit here and this circuit here. Now, remember to take out this cable once you're finished testing. Okay, that is vital. Otherwise, when you put on the power, this will just drop a direct short and cause the circuit to trip. Okay, or maybe even your main switch will trip. Now, and again, look at the situation before testing. Okay, as well as checking the continuity of the protective conductor, the meter will measure R1 plus R2, which when corrected for temperature and added to the value of ZE will help verify the earth loop impedance, ZS. Okay. Now make sure you practice this, especially when you're in the workshop. And I'm not going to read this out to you, you can read this for yourselves. But again, look at the main points and look at the method 1 and method 2 of testing. And you'll notice here it says this is a dead test. Okay, It means that the circuit has been isolated and locked off. Okay? And what this is showing you method 1 of testing. And again, as I said before, remember this link here. Remember to take that out after you have finished testing. Okay? Now if method 1 is used, again here you need to look at the information given. I'm not doing this for yourself, for you. You need to begin to be able to read through this and do it for yourselves. Okay, there's no shortcuts to this. And then you need to look at applying the formula in regards to the total resistance. Okay. Make sure you can see the information and that and here we have testing method 2. Now check that there are no parallel paths. Okay, so what he's saying here is that these extraneous bondings should, or supplementary bonding I should say, should be removed. Okay, you can see that they have removed the supplementary bonding. The supplementary bonding is bonding any exterior pipe work down to earth, but these can be reapplied after you have carried out the test. Okay. You can see that here you're testing earth continuity, that the continuity exists from your meter, etc. Okay, let's go back. Right, effectiveness of supplementary bonding. Okay, now supplementary bonding plays a very important part in electrical installation. It means that radiators, pipe work, and so forth has been bonded to earth. Okay. And where any doubt exists about the effectiveness of supplementary bonding, the resistance between simultaneously accessible exposed conductive paths and extraneous conductive paths shall fulfill the following conditions. Okay, and these are the formulas you will need to apply if it's for AC or whether it is for DC. Okay. And here you need to verify the results. On satisfactory test results, here it tells you what you should do, what you need to be aware of, what you need to make sure happens. Okay. Ring final circuits. Okay. Here's your basic ring final circuit. Okay. I'm not going to speak on this because you should be doing this already and you should know how to test now. Okay. So apply the methods of learning that you have learned, apply the knowledge you have acquired and implement it. Okay, ring final circuit testing. Okay. And again, this is information you should be familiar with. Make sure you follow it through. Let me make sure you can see it just for yourselves. Okay. Apply it, implement it. Okay. And here you have R1 plus R2 equals R end-to-end measurements plus R2 end-to-end measurements over 4. Okay. Okay. Now, multiple loops. The next stage of the test is to check that there are no multiple loops in the circuit. Okay. Loop within a loop. Now here, it's simply telling you here that the solid line here is the original circuit. Right? But somebody thinking that they were clever come here and try to run this, add a ring within a ring. Okay? But it doesn't quite work like that. Okay. And here you have testing for a true ring circuit. Okay. You have cable going out, you have cable coming back, and you're testing to make sure that these conductors are continuous, going and coming. Doesn't matter how much socket it feeds, that it should be within that ring circuit. Okay. Okay. Testing using the line and the neutral. Okay. Okay. Ring circuits in conduit or trunking systems. A possible reason for a change in readings is usually based on rings final circuits in conduit or trunking systems. If the conductors are not marked, how would the electrician know which is the outward and inward legs? Now you will need to always bear in mind the return leg and the outgoing leg. But when you get to the fuse board, you should be able to identify which is the outgoing leg and which is the return leg, basically. And the reason here is that you can look at and see how the testing in each case is somewhat different. Okay, so bear that in mind. Minimum fault current. Okay, all I'm going to do is to show you these over here, circuits over here, which gives an illustration of what they're trying to look at in regards to CPCs. Now again here I've simply said to create your own questions. Now if you create questions for yourselves, it allows you to use that information as revision. So please try and do that for yourselves. Okay, I hope you found this useful. Have a good day. Bye bye.